Hey friends, it's Ben again. This video had to be cut in two for various reasons I won't go into, but it's nothing bad. Just, yeah, I am in a classroom instead of in my office because there's no Wi-Fi in my office, or rather my computer can't see the Wi-Fi in my office. So anyway, we are looking at law of sine stuff. We're looking in particular at the side-side angle case. You have to read the section about it, okay? If you weren't in class, you'll have to just read the section. Even if you were in class, I would advise you to read the section, okay? And you'll see the things that we're going to refer to in these examples. All right, I'm going to share screen. And then screen mirror. All right, you should be seeing the iPad at this point. Okay, so the main trick here is that we need to see whether the side A that is opposite the angle A, see whether it is longer or shorter than this H. If it is shorter than that perpendicular distance, there's no way to make a triangle out of it, okay? So we're gonna go ahead here and calculate what the length of H needs to be. And since this is a right triangle here, then it would be B times the sine of that angle A. And if you grab a calculator and do the multiplication, you'll find out that that is 5.142 blah, 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 which is side A, okay? And that tells us that we have exactly one solution. We'll see an example here in a minute where you get two solutions. But fill in the stuff that we know, 5.142, what is it, meters? And then this B is 8 meters. This A is 40 degrees. This B, because of the fact that we got the B sine A to be equal to A, that tells us that the sine of B has to be 1, which tells us that the B is 90 degrees. Then you can figure out that your C has to be 50 degrees by subtracting. And then we'll write down that sine of 50 degrees over the length C, the only one we don't have known, is equal to, and you can pick either one of those. I think I like to go sine 90 degrees over the 8, because that seems like that's going to be easy to calculate. When you cross multiply, then cross multiply and divide, you'll get that the C is going to be equal to 8 sine 50 degrees over the sine of 90 degrees. And the sine of 90 degrees, of course, is just 1. And so I'm going to get in here on my calculator real quick and tell it to take 8 times sine of 50 degrees, divide by 1. I'm getting like 6.128, blah, blah, blah. Okay. I'm going to record it up here as being just 6, and that's not a 6, 6.1 meters. All right. Yay. And that's it. So this one here is the same sort of setup. I'd like for you all to pause the video here and try it out and then come back. Okay, so now you're back. And we are going to calculate H is going to be equal to the B. Well, I guess I should write the B down. The 15 centimeters, and the A is 7.5 centimeters, and the angle A is 30 degrees. All right, so the H should be the B, that's the hypotenuse, times the sine of the A. And I don't know why I put the letters in instead of just putting the numbers in. The B we knew was 15, and the A we knew was 30 degrees. That turns out to be equal to 7.5, which is your A, which tells you have one solution. That says that the angle B has to be 90 degrees. the angle C has to be 60 degrees. And now we have to figure out what the C is. If you want to, once you know it's a right triangle, you could just say B times cosine of A, you know. But if you don't spot that, then you can go ahead and say, I need my C to be equal to 15 sine 60 degrees divided by sine 90 degrees. And I will have to get to my calculator to see what that comes out to be. And I got 900, so I typed it in wrong. Times 60 sine. Oh, I must have forgot to hit the sine button. And I got 12.990, which I'm going to go ahead and round as 13.0 centimeters, just to be consistent with the other rounding that we had. All right. So now we're going to look at a different case here. And again, we know the situation is that side-side angle setup. If you had different, A's and B's and C's given to you, you would need to draw your picture to see whether you've got that case set up. But we know that we do. All right. And so here I'm going to calculate the H for comparison. And to do that, I will do B, which is 30, times the sine of 35 degrees. And as usual, I have to take my calculator and do that out. And I end up getting 17.207. You don't really need to be super exact because all these numbers are going to be far enough apart that you don't have to guess about them. So what we can see on that is that the H is going to end up being less than the A that we're given there. Okay, so the A is 20 centimeters. So the case that we have is that our H is less than our A, and our A is less than our B. So what we showed in class from that was that you have, no, don't do that. Okay, fine. We have two possible cases for any given length there. And let me see if I can trim that up a little bit. Yeah, okay. So we have two possible cases. I hope you can see there that that length that's in green is supposed to be the same thing, okay? So, with regard to this situation here, what was this, the 30 centimeters? When we're trying to figure this out, we can either have a C down here that's short or a C that's long, okay? And it's all going to depend on how, how this comes out. So what we do with this is to first find the one that has to do with the long value of C, and we will get that by solving for the angle B, okay? And so with regard to this, I am going to label that as B1, and the other option is B2, okay? So B1, C1, C1. And we will have to move this around a little bit so that we can see the options or see all the answers at once. But for getting the B1, we're going to go ahead and set up and say the sine of B1 over B is equal to the sine of A over A. And that tells you that the sine of B1 needs to be equal to 30 sine 35 degrees divided by 20. Okay. And I'm going to get an approximation on that. And then I'm not going to clear my calculator. Okay. So typing that in, I'm getting about 0.860, right? Don't clear your calculator because you're going to get your B or your B1 by doing the inverse sine of what have you got there. And so I'm going to just hit on my calculator's inverse sine. And so I've gotten out of that 59 degrees, right? I'm not going to ask you to be more exact than 59 degrees for it. Then I'm not going to ask you to be more exact than a degree. So I'll write down the 59 degrees here. And that allows us to figure out the other side, the other angle. So 180 minus 35 minus 59. So this will end up being 86 degrees. And now we're going to have to figure out the side that remains using law of sines again. Okay. But we need more space to write in because we've run out of space. So let me put an extra page in there, and I am going to write down that we know sine of C1 over little c1 needs to be, and I'm going to do sine A over A for reasons we talked about in class. It's better to use something that you didn't have to approximate as you went along. So I have to look back over here and say 35, 20, and 86. So sine 86 degrees for C1 equals sine 35 degrees over 20. Okay. So my C1 that I will end up getting should therefore turn out to be 20 sine of 86 degrees divided by the sine of 35 degrees. And I am going to do that in the calculator. And divide by 35 sine. Okay, I'm actually going to have to stop and look to make sure that those, yeah, that should be right. So I'm getting 34.784 out of it, which I'm going to round to 34.8 centimeters. And then we just kind of do our sanity check to see, is the largest side opposite the largest angle? It is. Is the smallest side opposite the smallest angle? It is. So hopefully your calculations are right otherwise. All right. So that is figuring out this triangle here. Now we have to go back and figure out this other possibility, the smaller triangle. And the smaller triangle will have a lot of pieces in common. So I'm going to take, and let's see, I'm going to take this stuff where we were calculating before and put it on this page. I wasn't sure that we could stuff it in here. And then I'm going to take this stuff here and pull it over to the other page. And well, that was super. Okay. So okay, so this is going to be not choice number 1, but choice number 2. Sorry for all the bookkeeping parts of this. And I will, oh, I will grab that, make a copy, and no, it's not supposed to do that. And I'm gonna leave a version there that has that. And then come over here, paste. I did not copy the whole thing, but it seems to want me to. All right. So the trick on this is that your B2 is going to be supplementary to your B1. So on the previous page, we found out B1 was 59 degrees. And so we'll end up with 121 degrees for our B2. Okay. And grab that and push it out of the way here. Okay. And the reason that we have that is that if you look, these two angles here have to be the same because it's an isosceles triangle. So if you take this angle and subtract it from 180, you get the thing that remains. All right. And then I'm going to grab that and erase it because we're looking at this case here. All right. Once we get that, then we can subtract and find out that this angle needs to be 24 degrees. And then you can write that the sine of 24 degrees over C2 needs to be equal to the sine of 35 degrees divided by 20. And that tells you that C2 needs to be 20 times the sine of 24 degrees divided by the sine of 35 degrees. And I'm going to just go ahead and do that on the calculator. 20 times sine of 24 divided by sine of 35. And I'm getting 14.182 something, which I'll go ahead and round as 14.2 centimeters. And then we're done with this one. Okay. All right. So let's go ahead and look at this one here. You are again going to pause the video and come back to it after you've tried it. All right. So pause and you're back. All right. So I am going to go through this part maybe a little bit quicker because of the fact that we've already taken a look at what we're doing on it. Okay. So the H is going to be 84 sine 50. And that is 64 point whatever. And so your 64 point whatever is going to be less than your 74, which is less than your 84. That tells us that we've got the two cases. Then we're going to go ahead and say the sine of B divided by 84 is equal to the sine of 50 divided by 74. Sine P is 84 sine 50 over 74. And I should do that right? Yeah. 84 times 50 sine divided by 74. Okay. I'm getting 0.8696. And so I'm going to get my b by taking the inverse sine of that. So, and I'm getting 60.408 degrees. I'm going to round that to 60 degrees. And that tells me that the remaining angle is 70 degrees. And we need to remember that that is B1, C1, C1. Now we're going to get the C1 to be equal to the A sine of the C divided by the sine of the A. And we will go ahead and get that. 74 times 70 sine equals divided by 50 sine equals 90.777. So I will round that as 90.8. What are our units? Inches. Okay. Now we are going to oh, and I should illustrate here with my green line like I did before. Okay, so now I'm going to take and copy this and make a new page and paste it. Okay, and remember that these are the twos now, the second option, not the first option. And I'll take that out, erase it, put a new one in. Yay. Okay, so our B2, you recall, is going to be 180 minus our B1. Our B1 was 60. So we're going to get 120 degrees here. That means we're left with 10 degrees on the C. And now we'll write down that the C2 needs to be 74 sine of 10 degrees divided by sine of 50 degrees. Okay. 74 times 10 sine divide 50 sine equals, I'm getting 16.774, which I'm going to round to 16.8 inches. Okay. And all right, stop share. I'm going to pause. I have to hit pause. And I have to check something. I'll be right back. And I'm back. Sorry about that. Somebody said they were coming in for office hours way early. And, you know, all right, so I'm going to share screen again. And screen mirror again. Come on. There we go. All right, so this setup here should be one that has only one solution. And the way we check it is like before to get our H. And the H is going to be this hypotenuse here times the sine of that angle. So we're going to say 15 times the sine of 50 degrees. And so I'm going to check there real quick. 15 times 50 sine equals, I'm getting 11.491. Okay. And so if you'll notice there, the H is, yeah, the H is actually more than the A, the 10 feet, right? And so what that means is that if you were trying to draw it here, your A that you are trying to reach down with can't actually reach down to the bottom. Right, so here's our A, and I should move the H out a little bit in order to illustrate there. And what that actually says is that there is no solution. Once you know there's no solution, you don't do anything else. Okay. All right. So I don't remember for sure whether this last one has that or not. So I'm going to ask you all to stop and check it. So pause the video and then come back when you've done that check. All right, now you're back. We're going to figure out what our H is, and it needs to be 80 times the sine of 20 degrees. And so I'm going to get that. And I'm getting 27.362-ish. And again, we have the setup that that is more than our value for A, which was 25. And so that says that, like before, you've got this situation where, oh, come on. You got this situation where you tried to draw this extra side, but it just wasn't long enough to actually work out. And so this is your H in red there. And if that should happen, then you say no solution. All right. Okay, so let me stop the share there, come back and say, all right. That situation where you end up with no solution may seem kind of weird to you because, you know, you can have that happen in math problems, but you don't have it happen in real world problems. You shouldn't have it happen in real world problems. If you make rounding errors, you could have a problem where you have put together the various pieces and, you know, maybe you were supposed to get a right triangle there and you kept rounding down over and over again with like 3 or 4 calculations and it misses. And then what that says really is that your propagation of errors can kind of mess you up, you know. Anyway, though, that's what I've got. I'm going to let you go. Hopefully this is helpful. All right, take care.